All right, let's see if we can't get everybody prepared for this final exam. All right, so let's start in the first group, which is solving an equation. So problem number 1, 2 times x minus 3 plus 3x minus equals, excuse me, I made a mistake on the first one, minus 2 times x plus 1. Okay. I can tell even after I do distribution this is going to be a linear equation, so I want to remember what the process for solving a linear equation. That means I'm going to get the x by itself and find out what it's equal to. So the first thing I'll do is distribute. So on this side, this gives me 2x minus 6 is equal to 3x, and remember to distribute the negative sign, minus 2x minus 2. Okay, then I want to combine the like terms on one side, so that gives me 2x minus 6 equals x minus 2. Okay, so to get the variables on one side, I'm going to subtract x from both sides. That gives me x minus 6 is equal to negative 2. Finally, I add 6 to both sides, and I get that x equals 4. Now on the test, I don't care if you put it in set notation or not. Okay, problem number 2. I have 3x times x plus 2 is equal to 20 minus x. Looks like it's going to be a quadratic because I'll be multiplying an x times an x, but the first thing I'm going to do is distribute. That gives me 3x squared plus 6x is equal to 20 minus x. When I'm solving a quadratic, what I need to do is set it equal to 0, and then I can decide what method I want to use. So I'm going to add x and subtract 20 from both sides. That gives me 3x squared plus 7x minus 20 is equal to 0. Okay. So I'm going to factor. You can use any method. You can use the quadratic formula. You can do anything. If it's not factorable, then you're going to have to use another method. And I'm always thinking about, well, are my solutions real solutions? Are they imaginary solutions? Am I going to have to write them in terms of I? But I'm going to factor this one, which means I'm looking for two numbers whose product is negative 60 and whose sum is 7. Well, those numbers are 12 and negative 5. 12 times negative 5 is negative 60. 12 plus negative 5 is 7. So I do that to split the middle term. So that gives me 3x squared plus 12x minus 5x minus 20 is equal to 0. I can now group these into 3x squared plus 12x plus, remembering that the negative goes only with the 5, negative 5x minus 20 is equal to 0. GCF here is 3x, and I'm left with x plus 4. Here I'm going to pull out the negative 5, and I'm left with x plus 4. So this becomes x plus 4 times 3x minus 5 is equal to 0. Now, again, you could have used any method you wanted. You could have completed the square or done anything. All right, so here I set x plus 4 equal to 0, so x is negative 4. 3x minus 5 is equal to 0. 3x equals 5, and x equals 5/3. Okay, trying to save some paper here, so let's do number 3 over here. Here I have x plus 4 over x squared minus 4x plus 2 over x is equal to 2 over x minus 4. Okay, this is a rational equation. It has a variable in the denominator. So what I have to do here is find the least common multiple of the denominator and multiply through by that. So for the LCM, I have x squared minus 4x, which is equal to x times x minus 4. This denominator is just x, and this denominator is x minus 4, which is just x minus 4. So my least common multiple is going to include an x and an x minus 4. Okay. Well, my first term here is already x plus 4 divided by x times x minus 4. So I don't have to do anything with that. But this one where I have 2 over x, well, let me think about this another way. I'm going to multiply everything x times x minus 4. So x times x minus 4, and that's all going to equal 2 over x minus 4 times x minus 4. Okay, the whole point of doing this is making sure that I get rid of the denominators. Okay. So when I do this, this cancels and this cancels, so I'm left with x plus 4 plus, and here the x's cancel, so I have 2 times x minus 4 is equal to, and the factor of x minus 4 cancels, so this equals 2x. Okay, this looks like it's going to be a linear equation, so I have x plus 4 plus 2x minus 8 is equal to 2x. So that gives me 3x minus 4 is equal to 2x. I'm going to subtract 2x. And I'll continue up here. So that gives me x minus 4 is equal to 0. When I add 4 to both sides, I get that x is equal to 4. But now I have to check and see if it makes any of my denominators equal to 0. Okay, so I want to check in my denominators. Okay. All right, so I want to know if 4 squared minus 4 times 4 is equal to 0. The answer is yes. So this is an excluded value. So there is no solution. Okay, let's do number 4. All right, so this is 2 times the square root of 3x minus 4 plus 2 is equal to 8. All right, so here we have a radical equation. Okay, so what I have to do is I have to get the radical by itself, and then whatever the index is, I'll take everything to that power. So I'm going to subtract 2 from both sides. So that gives me 2 times the square root of 3x minus 4 is equal to 6. When I divide by 2, that gives me the square root of 3x minus 4 is equal to 3. The index is 2, which means I take both sides to the second power. I get 3x minus 4 is equal to 9. Add 4 to both sides, I get 3x equals 13. Divide by 3, and I get x is 13 over 3. Now, I also have to check this because I have to see my radicand has to be greater than or equal to 0. So I want to check 3 times 13 over 3 minus 4, is that greater than 0? Well, this is 13 minus 4, which is greater than 0, so this is a solution. Okay. 5 is an absolute value, so I have 3 times the absolute value of 3x minus 5 is equal to negative 15. And just like a radical equation, I have to get the absolute value by itself. Okay, so I'm going to divide both sides by negative 3. And that gives me the absolute value of 3x minus 5 is equal to 5. Okay, I can do that because the absolute value of anything is non-negative. Okay. But remember what this means. I'm looking for where the absolute value of it is 5, which means it's 5 units away from 0. So that means that 3x minus 5 is equal to 5, or 3x minus 5 is equal to negative 5. So when I have an absolute value equation, I have 2 to solve. Okay, so I'm going to add 5 to both sides. I get 3x is equal to 10, and x is equal to 10/3. Here I have 3x when I add 5 is equal to 0, so x is equal to 0. And there are no restrictions on this for the domain. I can put anything in there and take the absolute value of it. Okay. 6 is an exponential equation. Okay. I cannot turn 5 into a power of e, or e into a power of 5. Excuse me. So what I'm going to do is to get this out of the exponent, I'm going to take the log of both sides. Since it's e, I want to take the natural log of both sides. So I'm going to do the natural log of e to the 2x minus 1 is equal to the natural log of 5. Now, either remembering the rule that the natural log of e to the x is x, or I can know that I can bring this around front. This gives me 2x minus 1 times the natural log of e is equal to the natural log of 5. Well, the natural log of e is 1. So this just gives me 2x minus 1 is equal to the natural log of 5. Okay. So I'm going to have to solve for x and get the exact answer, and then put it in my calculator to find the decimal approximation. Okay, so I'll add 1 to both sides, so that tells me 2x is equal to the natural log, and I'm going to go ahead and put this in parentheses right now, plus 1, and then I'll divide everything by 2. So this is the natural log of 5 plus 1, all of it divided by 2. This is the exact answer. And if you have a question like this on the test, you're going to have to provide an exact answer and then the approximation. And we normally do that to 4 decimal places. Okay. All right, so if I put this in my calculator, I have the natural log of 5 plus 1 divided by 2 and I get 1.3047. And I'm going to have to fix that. Okay. Okay. All right, so we're done with solving equations now. Yay. Okay, now we have to start solving inequalities. They're very similar to solving equations, but there's just one thing that we have to think about. If we multiply or divide by a negative number, we have to flip that inequality symbol. So I have 1 minus 3 times x minus 9 is less than 5 times x plus 6 minus 2. Okay. This appears linear, so I'm going to just go ahead and simplify both sides. So this becomes 1 minus 3x plus 27 is less than 5x plus 30 minus 2. I think I will continue to simplify 1 plus, so this gives me negative 3x plus 28 is less than 5x plus 28. Okay. Well, if I subtract 28 from both sides, that goes away, so I have negative 3x is less than 5x. Okay. I like to have my variables on the left, so I'm going to subtract 5x from both sides. So that gives me negative 8x is less than 0. But I'm going to divide by negative 8, which means I have to flip the inequality symbol. So that tells me, now I have to flip, so that tells me x is greater than 0. If you wanted to put it in interval notation, it's going to be 0 to infinity. Okay. Okie dokie. Number 8. Okay, so there are a couple ways to do this. If I have x times x plus 2 times x minus 3 is greater than or equal to 0. Okay. And you can do it either way. All right, so part of it is knowing about polynomials. This is a polynomial, and the degree is 3, because if I multiply x times x times x, that gives me x to the third plus, and then whatever. And the leading coefficient is positive. Okay. And then I know that my zeros are 0, negative 2, and 3. They all have a multiplicity of 1. Okay. So I can just sketch the graph real quickly. An odd degree with a positive leading coefficient means the ends go in opposite directions. It crosses at negative 2, at 0, and at 3. So to the left here it goes down. It goes on through. It comes back down. And it goes on through. So if I want to find where this is greater than or equal to 0, then it's where it's above the axis. So it would be from negative 2 to 0, and from 3 to infinity. Now the other way you can think about it is you can do it just on a sign chart like we did for the others. So I know that I have zeros at negative 2, and at 0, and at 3. So I can just test at any point in there and see if it's positive or negative. So for here, I'm going to test x equals negative 3. So that gives me negative 3 times negative 3 plus 2 times negative 3 minus 3. So that's negative 3 times negative 1 times negative 6, which is negative. So this is negative. So everything down here means that this is less than 0. Okay. For in here, I'm going to test x equals negative 1. So negative 1 times negative 1 plus 2 times negative 1 minus 3 gives me negative 1 times 1 times negative 4, which is positive. So since this is positive, this means it's greater than 0. And then for in here, let's test x equals 1. So 1 times 1 plus 2 times 1 minus 3 is 1 times 3 times negative 2, which is negative. So here it's less than 0. And let's test x equals 4. So that gives me 4 times 4 plus 2 times 4 minus 3. 4 times 8 times 1 is positive. So since this is positive, this is where it's greater than 0. And of course, this is where it's equal to 0. So it's greater or equal from here over and from here to here. So this gives you the same information that you get if you remember about how to graph a polynomial. Okay. Number 9. Oh, we have a compound inequality here. So I have negative 4 is less than or equal to 5x plus 1 is less than or equal to 0. Okay. All right, so the goal is to get the x by itself here. And the only thing you have to remember about this is now you have your inequality as 3 pieces. You can still do anything you want, you just have to do it to all 3 pieces. So I'll start by subtracting 1 from everything. So that gives me negative 5 is less than or equal to 5x is less than or equal to negative 1. Oh, this is 21, I'm sorry. So this is 20. I knew something was wrong there. Okay. And then I just divide everything by 5. Since I'm dividing by a positive number, I don't have to flip the inequalities. So I get negative 1 is less than or equal to x is less than 5. Or in interval notation, negative 1, 4 for the parentheses. Okay, for 10, I have x divided by x minus 4 is less than 0. Okay. Since it's a rational, I need to know the zeros and I need to know the asymptotes. Okay. Well, the zeros are where I set the numerator equal to 0, so x equals 0. And the asymptote is where it makes the denominator undefined, so that's x minus 4 is equal to 0, so x equals 4. Here you are going to want to use a sign chart. Okay, and so you know you have a 0 at 0, and at 4 you have an asymptote. It cannot be included, regardless of what happens here. All right, so I'm going to do the same thing. I'm going to test something less than 0. So let's test x equals negative 1. So negative 1 over negative 1 minus 4 gives me negative 1 over negative 5, which is positive. So this is going to be greater than 0. If one test point over here is positive, everything is positive. All right, so let's test x equals 1. So 1 over 1 minus 4 is going to be 1 over negative 3, which is negative. So that means everything in here is less than 0. If it's less than 0 at 1, then it's going to be less than 0 for everything between 1 and 4. And here, let's just test x is 5. So 5 divided by 5 minus 4 is 5 over 1, which is positive. So this is greater than 0. Okay, so I'm looking for where it's less than 0. Okay, so I'm not going to include the 0, and I never include the asymptote. So this from 0 to 4, so my solution is everything between 0 and 4. Okay. I'm going to quit and start a new video.